All right, so we've got another deep dive ready to go here. And this one comes straight from our listeners who are dealing with, well, a pretty frustrating problem. They've given us a bunch of info on troubleshooting these Kubernetes node failures. The thing is, they only seem to happen when the cluster's under a really heavy load.
Yeah, intermittent failures like that can be a real pain to track down. It's like everything seems fine most of the time, and then boom.
Exactly, and that's why we're diving in to help extract, well, I guess the most important steps and insights. We'll try to give everyone listening a solid framework for understanding and then hopefully actually addressing these kinds of failures.
Yeah, absolutely, yeah.
And just so everyone's on the same page, we're going to cover a pretty wide range of stuff. We'll hit on initial assessment, how to analyze if you've got resource constraints going on. Then we'll look at individual nodes and then the cluster as a whole. And then if things are really tricky, we'll even touch on some more advanced debugging techniques.
Right. Got to have that whole toolbox ready.
For sure. And of course, no deep dive would be complete without talking about how to actually remediate these issues, right? So strategies for preventing them from cropping up in the first place.
Love it. Sounds like a plan.
Okay, so let's jump right in. When you see these signs, nodes acting up under heavy load, what's the very first thing you do? Where do you even start?
Well, you got to get that lay of the land, right? So kubectl is your best friend here.
Of course, good old kubectl.
Yeah, you want to use that to check the status of all your nodes. And while you're at it, take a close look at the recent events that have been logged. See which specific nodes are failing and if there are any error messages that just jump out at you. And then, super important, you got to see if the Kubernetes control plane itself is healthy.
Control plane, got to make sure the brains of the operation are working, right?
Absolutely. Now, the really crucial part here is to try and connect these initial findings with what your application was doing at the time, like was there a big spike in traffic, maybe a new deployment, anything like that that happened right before things went sideways.
Ah, so you're saying building that timeline is key.
Oh, it's huge. Often just seeing the order in which nodes failed, or even specific error messages, can point you right at the problem. Like maybe there's a shared dependency that's messing things up, and that's causing those nodes to drop one after another.
Interesting. So it's like detective work, really, following the clues. Okay, so we've got this initial snapshot. Now what? Where do we focus our attention?
Okay, well, whenever you're dealing with high load, one of the first things you got to suspect is that you're running into some resource constraints somewhere.
Right. Makes sense.
Yeah, so start by checking those usual suspects, CPU and memory usage. But don't stop there. You also got to look at disk pressure.
Disk pressure. Now, that could be a couple of things, right?
Exactly.
Yeah.
You have to consider both I/O, like how fast your disks are reading and writing, but also the number of inodes you have available.
Ah, inodes. Easy to forget about those.
Definitely. Okay, once you've checked all that, you got to dive into how your pods are actually defined. Are they requesting enough resources? And super, super important, are you setting limits correctly?
Limits. Yeah, that's a classic.
Oh, it's a common culprit. I mean, if you don't set those limits, things can go haywire really fast under high load. Now, don't forget, there's also the whole world inside the containers themselves.
Oh, right. It's not just the Kubernetes stuff.
Exactly. You could have memory leaks within your application, or maybe the CPU's getting throttled for some reason. All that stuff can definitely lead to those node failures you're talking about.
So we've gone from the big picture down to the specifics of resources. Let's say we've checked all that and things still aren't clear. What's the next layer we peel back?
All right, if the problem's a bit sneakier, it's time to zoom in on those individual nodes that are giving you trouble.
Okay, get down to the nitty-gritty.
Yep. First stop, those kernel and system logs. You're on the hunt for those dreaded out-of-memory errors, the OAM kills as they're called. Or maybe there's some hardware issue lurking in the background. Then you got to take a look at your container runtime.
Ah, so we're talking Docker, container CRIO, that sort of thing, right?
Yep, exactly those. Make sure they're all happy and healthy. Now, networking problems can also rear their ugly heads here. Maybe your connection tracking table's full, or you've got some errors topping up on the network interfaces. And finally, don't forget those kubelet logs.
The kubelet, yeah, Kubernetes little helper on each node.
That's the one. Its logs can tell you if Kubernetes itself is struggling to manage the pods on that node. Are pods constantly restarting? Is there any CFS throttling going on? Or maybe the kubelet's having trouble talking to the API server.
So that's a pretty deep dive into a single node. But what if it seems like the problem's bigger than just one node? What if it's more of a cluster-wide thing?
All right, well, if that's the case, you got to shift gears and think at that cluster level. Wow. First, think back, were there any deployments recently? Sometimes that can trigger weird behavior.
Ah, so a change in the environment might be a clue.
It definitely could be. Now remember, etc., that's Kubernetes' central data store, and its health is absolutely critical. So you got to check for things like latency issues or problems with leader election.
Etc. The heart of Kubernetes, got to keep that beaten strong.
For sure. And don't forget about your CNI plugin. That's what handles the networking within your cluster. Make sure the network itself is stable and not causing problems. If you happen to be running load tests, see if those failure patterns you're seeing line up with the testing.
So correlating events again, like we talked about at the beginning.
Exactly. And, sometimes the culprit can be something like kubeproxy or a bunch of complicated iptables rules that end up becoming bottlenecks.
Wow, so we've really gone through a lot here. But what if we've checked all this stuff, nodes, resources, the whole cluster, and we're still scratching our heads? What happens when we need to bring in the big guns?
Okay, well, if you find yourself in that situation, it's time to break out those more advanced debugging tools. One option is Node Problem Detector. It can automatically detect and flag a lot of system-level issues that might be causing trouble.
So it's like having an extra set of eyes watching those nodes.
You got it. Another powerful technique is chaos engineering, but in a controlled way, of course.
Chaos engineering, that sounds a little, well, chaotic.
It can be, but the idea is to intentionally introduce failures into your system.
Wait, intentionally break things?
In a controlled way, yeah.
Yeah.
It sounds counterintuitive, but by doing that, you can actually reproduce those intermittent problems in a safe environment and get a better handle on what's triggering them.
Okay, I'm starting to see how that could be useful.
Right. And then there's extended tracing. This lets you record pretty much every single interaction between your application and the operating system kernel.
Wow, so we're talking super granular here.
Extremely granular. It can give you incredibly detailed insights into performance bottlenecks or the exact points of failure.
Sound powerful, but probably a lot of data to sift through.
Oh, yeah, definitely. But sometimes it's the only way to get to the bottom of things. Now, you can also try analyzing those squig group constraints and your kernel parameters. That can help you fine-tune how the system behaves under pressure.
All right, so let's say we've gone through all this, we've investigated everything, and we think we finally found the root cause. Now, how do we actually fix it and, even more importantly, prevent it from happening again? What are our options for remediation?
Okay, well now it's all about putting those proactive strategies into place. And the foundation of all this is, you guessed it, proper resource management. Making sure you're setting those requests and limits correctly for your pods, that's absolutely key.
We keep coming back to those requests and limits.
They're just that important. Now, you should also look into pod disruption budgets, those PDBs, and quality of service classes.
Okay, quick reminder on those.
Sure. So PDBs let you define how many replicas of your application need to stay up and running, even when you're doing things like voluntary disruptions, like rolling updates. And QoS classes help ensure that your most critical workloads stay available no matter what.
Ah, so it's all about making sure those important services don't get knocked offline.
Exactly. Now, another thing to implement is node pressure eviction.
Node pressure eviction, that sounds a bit intense.
It's actually about being gentle. It basically makes sure that when a node's running out of resources, pods are evicted gracefully.
Ah, so it's preventing a sudden crash by proactively moving things around.
Exactly. And of course, you can use horizontal pod autoscaling and node autoscaling to handle those sudden spikes in load.
Right, scale up when things get busy.
Yep. And to make sure things are running smoothly, you want to spread those workloads around intelligently. So use affinity and anti-affinity rules. Make sure you're taking advantage of topology spread.
Right, so don't put all your eggs in one basket, so to speak.
Exactly. And honestly, I can't stress this enough. Enhanced monitoring with proactive alerts is absolutely essential. You want to know about problems before they become full-blown outages?
So it's not just about fixing things when they break, it's about knowing they might break before they actually do.
100%.
Yeah.
And one last thing to consider is setting up specialized node groups. If you have certain workloads with very specific needs, you can create nodes tailored just for them.
That makes a lot of sense. So we've covered a lot of ground here. We started with basic kubectl commands, then dug into those resource constraints and node-level troubleshooting. We even talked about cluster-wide issues and then those advanced debugging techniques. That's a pretty comprehensive approach to a really tricky problem.
Yeah, we've gone through the whole toolkit, really. But hopefully this gives anyone dealing with these intermittent node failures a solid framework for figuring out what's going on and, well, getting things back on track.
Absolutely. And, it really makes you think about how much smoother your Kubernetes experience could be if you just went ahead and implemented a lot of these remediation strategies right from the start, even before you have any problems. You'd be building that stability and resilience right into the foundation of your cluster. Definitely food for thought. Well, thanks for taking this deep dive with me.
My pleasure.
All right, that's it for today. We'll catch you on the next deep dive.